This is one of the question from neet 2025. The question is basically from you can consider equilibrium concept, that is net force on the body and the net torque on the body must be zero in order to be in a equilibrium. Let us consider the forces. First, I am considering the body's weight as 200 Newton because it is 20 kg and the length of the rod is 5 meter, and let us write a normal force at the point of contact N1 and N2, and also they have mentioned the wall is smooth, so there is no friction on the wall, but there is a roughness on the floor, and they have mentioned the angle 60 degree with the wall, which means this is 60 degree, then we can consider this one as 30 degree. So now let us write the net forces along x axis and the net forces along y axis. So first let us mark the friction. So now there is a friction, the rod tends to move towards right at this point, then friction must act towards left, let us write it as a friction. Now net forces along y direction, N1 is acting up, 200 is acting down, then N1 must be equal to 200 Newton. In the same way, N2 is acting towards right, then friction is acting towards left, then N2 must be equal to friction. Good. Now let us write torque. So let us take torque about point P. Let us take torque about point P, that must be equal to 0 because the body is in rotational equilibrium. When I take a torque, N1, torque provided by N1 and torque provided by friction should be equal to 0 because both forces are passing through the same point. Let us consider torque provided by weight 200 Newton and the perpendicular distance is this. This is the perpendicular distance. The perpendicular distance is nothing but L by 2 cos 60. L by 2 is nothing but 2.5 meter. Cos 60 is root 3 by 2. Should be equal to torque created by this weight, try to rotate like this, and torque created by N2, try to rotate like this. Torque created by N2 I am directly replacing with friction multiplied by the perpendicular distance is L sin 30. L is nothing but 5, sin 30 is 1 by 2. So let us cancel this 2.5, it is 2.5 get cancelled, then this 2 100 times. So now we have the frictional force from this calculation, it is 100 root 3 Newton, that is our second option.